Istanbul. No more bustling city exists anywhere on earth.
Bir buçuk saat.
But to cross the Bosphorus, which not only divides Europe from Asia, but Istanbul from itself, requires a kind of Eastern fatalism, or a great deal of patience. Having driven for several days from all parts of Europe, these lorries, vital to Turkey's trade, queue for several more days to make the next kilometer. In fact, a whole economy has grown up to help pass the waiting hours. "17 ferries, very effective in their own right, work night and day, fighting a losing battle. To end the chaos in city streets and get traffic and trade streaming across the Bosphorus is the thinking behind the new peripheral highway scheme, of which the Bosphorus Bridge is the key link. For millions of years before the storks began delivering the human race, these birds have made an annual pilgrimage from all over Europe to cross the Bosphorus, carried by thermal currents which arose when the world was young. "2,500 years ago, Xerxes led the Persian armies to their fate at Marathon across a pontoon of boats over the Bosphorus. "25 centuries later, a bridge is to be built on the same spot. Now it is the summertime of 1970, and it is not easy to visualize what things will look like in 3 years' time. To the observer, men are just ripping out large holes in the ground. Let us digress for a moment and see why. Before anything can happen above ground, much must be made to happen below. Foundations for the anchorages and towers must be hewn out of whatever ground lies beneath. On the European side, the foundations rest on contorted mudstone of schistose rock of Upper Devonian age, folded during mountain building periods. The orientation of rock changes rapidly, often within a few meters. On the Asian side, the bedrock has a different geological basis, being mainly limestone, some of it fissured and containing clays and other substances. The whole Bosphorus is in part a geological fault zone. resulting in considerable variations of rock conditions. An early problem confronted the engineers excavating for the tower foundations at Autocoy. Sheet pile cofferdams, retained by concrete rings, should have gone down to a depth of 14 to 16 meters to sound bedrock. At this depth, instead of sound rock, clay schist and other soft materials were still having to be removed in the south cofferdam. An ingress of water had to be dealt with. And damage to the sheet pile wall repaired. After that, it was carry on digging. 18 meters, 20 meters, through autumn, and as the first winter chilled the air, at 25 meters, more than half as deep again as originally envisaged, the foundations can be keyed into sound rock. Now the vast holes in the ground can be filled with a man-made material of immeasurably greater strength. Concrete. To create the great cylinders with their reinforcement stressing bars and strands on which the towers, each capable of taking a vertical load of 30,000 tons, can be safely erected. Although nature put the contract behind schedule, much of the time is made up by human endeavor. To defeat nature, the anchorage excavations too went much deeper than originally envisaged. Concrete blocks tied to the rock behind stabilized the retaining walls prior to construction of the anchorages. But more problems were to appear. Cracks in one wall, caused by a large void at 30 meters depth, created a danger of the wall collapsing into the excavation. A bold decision was taken. Knock it down and start again. The problem was solved at the cost of time. But time must take second place to safety and future stability. Built in open excavation on a more suitable gradient, this part of the anchorage was soon assuming its new look. For several months after completion of the chambers, the anatomy of the anchorages is carefully built up. Great accuracy is required, and each tube aligned to take the various strands when the vital cable spinning begins. The anchorages will transfer the pull of some 16,000 tons in each of the two main suspension cables into the ground and the now secure bedrock. By the spring of '71, the foundation problems are solved, and from great ships that pass this way, new landmarks will soon become a daily feature. The men from England have arrived to take over from their German partners. Men like Frank Dinsdale, Cleveland's project manager, with site manager Otto Kotthaus of Hochtief, senior engineers and adequate rations of chai, cement the relations built up from afar during the previous year.
But not to a point that we can't deal with on the site.
For the next 2¼ years, all the action will be above ground and will reach ever higher levels above both land and sea. The very first of the above-ground operations is the positioning of the tower base units. This calls for absolute precision. Once these base sections are placed, there is no possibility of altering the plumb of the towers at any later stage of erection. Under the terms of the international loan for the bridge, Cleveland had to subcontract some of the work to other European countries. Much of the steel for the towers was fabricated in Italy, within sight of another, if less perpendicular, tower. A few kilometers from the leaning tower are the Livorno works of CMF. While foundations were being built on the Bosphorus, steel fabrication here, as at Darlington, has been proceeding apace. Nearly 5,000 tons of steel will go into the towers alone. The works doors have to be widened to allow the train to carry the panels out and into the Italian countryside. The railway to Livorno docks may look a gardener's nightmare, but by removing a few signals, overhead wires and other obstructions, it admirably fulfills its function. Some days later, the panels are offloaded at Istanbul docks, one of hundreds of shiploads from dozens of ports serving the project. For several months to come, the climbing tower cranes, one to each leg, will be the major tools on the job and will rise with the towers. Each panel, weighing some 20 tons, is lifted by the cranes which are operated by winch at ground level. A tower leg is a hollow steel box stood on end. Each section, consisting of 4 panels, is 20 meters long. At this stage, it is still possible for men to signal and even shout at each other from ground level. Later, radio communication will take over as men and towers reach up towards the clouds. Each of these panels is tailor-made to fit in one place only. Each bolt hole and washer is pre-positioned. For inspection and careful checking, the steel erectors occasionally taste the high life. And by midsummer '71, we are a quarter of the way up. In midsummer too, activity is at its height on the world's most fabled waterway. Seraglio Point and the Golden Horn. Alexander the Great marched through here on his way to India, and the Crusaders came this way to fight for the Holy Land, when not fighting each other. The harem of Topkapi Sarai, the Blue Mosque and Santa Sofia, Dolmabahce. The very names conjure up a whole kaleidoscope of legend and history. Christmas morning, 1971. For 3 days, the wind has had its way, and though the men had worked the previous weekend to have Christmas off, many are destined instead to have a ding-dong merrily on high, 165 meters high, on the tower tops at Bela Bay. Before the final lift begins, the crane is climbed for the last time. As the tower legs taper slightly, each panel has its predetermined position and is not interchangeable. Its placing must be exact. The panels are lifted in very close proximity to the already erected part of the tower. If caught by the wind on the way up, the lifting wires could become twisted, or the panel bump into the tower leg and cause damage.
Okay, Chuck, it's clear now.
Critical wind speed for this operation is only 25 kilometers an hour.
Check on the north side, please.
Radio contact and guidance of men by engineers and foremen is cool and deliberate, even when aided by the occasional homely phrase, which seems to evoke the right response, whatever other language barriers may exist. One of the last of the 128 panels is positioned, and across the Bosphorus at Ortaköy, the other tower is finished and ready for the next stage of construction. As the bridge timetable reaches towards halfway stage, so too the peripheral highway reaches out to meet it, for both must be ready at the same time. From the surrounding countryside in both continents, a new feature on Istanbul's skyline makes its presence seen. In the small villages of Asia Minor, some of the hardness will soon be taken out of life, as the bridge speeds trade and communications between town and country. Bridging not only 2 continents, but 2 centuries. Another winter and spring of sowing and ploughing, and once again it is blossom time for the bridge. Great steel mesh walkways have been slung between the towers, and soon will serve as a production line in the sky for the aerial spinning of the suspension cables. At the base of the Ortaköy anchorage, the spinning machinery is being set up for an early summer start. All that is now required to set these wheels turning is the wire for the cables. As part of the international character of the bridge contract, the manufacture of this is entrusted by Cleveland to the German firm of Arbed, Felten and Guillaume. The Rhine at Cologne, home of one of the world's largest wire works. Through numerous processes, the metal becomes a series of long, continuous hot rods. Eventually, these are drawn and become wire. Passed through zinc baths and other processes, the final galvanized product becomes cable wire of 5 millimeters diameter with a tensile strength of 165 kilograms per square millimeter. In the long run, it is the strength of this wire, 5,500 tons of it, on which the safety of the bridge will depend. The total length of wire used in spinning the cables would, in the words of Shakespeare's Puck, put a girdle round the earth, and some to spare. 40,000 kilometers of it. All of it eventually reeled and dispatched from this nerve center at the Ortaköy anchorage. Cable spinning calls above all for speed and teamwork. And both are based on a very sophisticated communication system. One wheel returns empty from its 3-kilometer round trip to Asia and back, down to the dispatch area. Each strand consists of 550 single wires, and each main cable will have 19 strands. At each anchorage, the wires are placed over the strand shoes. If each trip of wire took just 1 minute longer, it would add a whole week to the contract time. The wheel carrying 2 bites or 4 wires travels along the production line, past numerous willing hands. All through the hot summer of '72, the wheels go back and forth, sometimes in temperatures more akin to a Turkish bath. As the wires are placed over the strand shoe at Bela Bay, the other wheel is loaded at Ortaköy and ready to begin one of the 5,000 return trips to Asia, putting over 10,000 parallel wires into each cable accurately and fast. And when the sun goes down behind the minarets of Istanbul, work on the bridge continues under a canopy of stars. For when each strand is complete, its final adjustment is carried out in the cool of Bosphorus nights. The bridge site is not the only place on the Bosphorus where the bridge is being built. 3 kilometers on towards the Black Sea stands Rumeli Castle, built by Mehmet the Conqueror to lay siege to and conquer Constantinople for Islam. Beside the old battlements on the Asian shore is Göksu, now a vast fabrication yard where the separate sections from Darlington and Livorno are being assembled and welded into 60 aerofoil boxes, each weighing 150 tons, and which will comprise the main deck of the bridge. Each box is assembled against and matched to its neighbors to ensure an accurate fit when in position on the bridge. A turntable enables it to be moved to its place prior to barging it up the Bosphorus to the bridge site. This purpose-made barge is ballasted to move in under each box. When accurately positioned, water is pumped out of the barge, enabling it to rise up and carry the box out. Now a strange new craft can be seen, making its journeys up and down the Bosphorus. We are into January of 1973, the last year of construction. The main deck has started to grow. When the lifting tackle is in place on the unit, the barge moves out from under and stands guard. The weight of the unit is now taken by the lifting gantry straddling the walkways. The lift from barge to deck, some 65 meters above sea level, takes about 50 minutes. In a good week, 9 of these units are lifted. But there are not many good weeks, for the wind is making a desperate effort to stop the job. Critical wind speed is 50 kilometers an hour, but for days it blows at 65 and gusts up to 80. This twists the lifting wires and could cause the unit to pitch and yaw, or create damage if in collision with the assembled part of the deck.
Steady on the south, nice and steady.
The units are hung from the suspenders and the deck temporarily bolted together. By the end of February, with the wind still blowing and the rain falling, work has begun on the approach viaducts. On February the 26th, the worst storm in living memory brought winds of 132 kilometers an hour at the docks and into the boat, a spectacular 55 meters with a minimum of deflection. As each span is completed, cross girders are positioned and preparations made for placing the composite steel and concrete deck. For the concreting operations, the men of Hochtief return once more to site. As winter draws to its reluctant close, the main span too has won its war of attrition with the wind. The end unit, which fits to the portal and tower, is on its way up. Only one gap, like a missing tooth, remains to be filled. Now, too, the welders take over, as the deck takes on its final shape. From portals to mid-span, the deck cambers some 8 meters. The triangulated suspenders are designed to supply a valuable element of structural damping and prevent oscillation caused by high winds. On March the 26th, a month to the day after the great storm, the barge carries the last unit on a lap of honor of the Bosphorus before being lifted. A small gap in the deck and a large gap in history are simultaneously closed. Government officials, consulting engineers, and bridge builders duly mark the occasion. There is still much to do, but now is a moment for celebration, and for staff and wives, time for a little Eastern promise. There are various ways of toning up stomach muscles. To ensure proper adhesion to the steel deck, the mastic wearing course is laid by hand, as only these craftsmen know how. Oddly enough, as the final completion stages are reached, the labor force reaches a peak. The cables are wrapped with a soft protective wire and painted. In fact, everything seems to be getting painted. Unlike the deep truss decks of earlier suspension bridges, this resembles a graceful, if gigantic, aircraft wing, with aerodynamic properties contemptuous even of winds of 200 kilometers an hour. The bridge is designed to withstand a shock acceleration in the bedrock in any direction, such as occurs in earthquakes experienced in this area in past times. In such an event, which heaven forbid, the safest place in Istanbul would probably be on this bridge. When any new major structure is built in a large city, the question is inevitably, and rightly asked, will it spoil the visual heritage? The question is especially relevant here, where the skyline is one of indescribable beauty, largely created by Sinan, architect to Suleiman the Great, and who did for Istanbul what Wren did for London. The bridge presents a visual counterpoint, which they would surely have approved, as do the citizens of modern Turkey. Building the bridge has shown the talent and workmanship possessed by the Turkish people. To the platers, to the welders, to the steel erectors, to them, Their British and German colleagues pay tribute. In 5 years, the bridge will have paid for itself, and a handsome annual revenue will add to the prosperity of Turkey. With the completion of the peripheral highway, a stream of traffic will become a torrent, with 22,000 vehicles crossing every day, from Europe to Asia in 2 minutes, and an overland route all the way from Calais to Calcutta. Centuries of hoping, decades of thinking, years of planning, and incredibly, 3 short years of construction. And there it is, the beautiful bridge over the Bosphorus.